So example number 20, page 76, solve. It is said solve, that means you have to find out the general solution, and we learned in our previous lecture that general solution of sin x, I am writing here, general solution of sin x is equal to sin y is x is equal to n pi plus minus 1 raised to n into y, n belongs to z, right? Then cos x is equal to cos y, theorem number 2. This double implies x is equal to twice n pi plus or minus y, n belongs to z. And third one, tan x is equal to tan y. This double implies x is equal to n pi plus y, n belongs to z. So these three are your general solution of sine, cos and tan. If you have sec, then you have to convert in cos, and cosec then convert in cosec, then convert in sine. And if you have a cot, then convert him into tan and write down the solution of this as I discussed in previous lecture. So it is given sin x is equal to minus root 3 by 2. So sine is negative, and this is the value for sine 60, that is pi by 3. So this is a value for pi by 3, right? So this is the value for pi by 3, and sine is given negative. Sine is negative in all s. So first two quadrant sine all positive, second quadrant sine positive. So sine is negative here, right? Sine is negative here, and this is pi by 3. In third quadrant it is pi plus, that is pi plus pi by 3, right? And this is 2 pi minus pi by 3 as we discussed, right? Either you can write in first quadrant as it is, second quadrant 1 less, third quadrant 1 more, that is 4 pi by 3. So answer of this is again 4 pi by 3. If you check, 3 plus 1, 4, and this is 1 less than the double is 6, 1 less, that is 5 pi by 3. So answer of this is also 5 pi by 3. Sorry, this is 3. So this is 5 pi by 3, 6 minus 1. So out of this you have to write minimum value. Either this you can write, then answer is also same, but the looking wise this answer is different. But we are going to take a first value, that is third quadrant first, then fourth quadrant. So we are going to take 4 pi by 3. So this is therefore sin x is equal to sin 4 pi by 3. Sin x is equal to sin 4 pi by 3, that is minus root 3 by 2, right? So instead of minus root 3 by 2, this is lies in third quadrant, and third quadrant is 1 more than the denominator in numerator. So 1 more, that is pi by 3 standard value, 1 more is 4 pi by 3. Either pi plus theta, you know, this is as it is theta, this is pi minus theta, this is pi plus theta, and this is 2 pi minus theta. You may remember like this, either as it is 1 less than the denominator, 1 more than the denominator, and 1 less of double of denominator. You can remember like that, right, as per your memory power. So now this is sin x is equal to sin y. So sin x is equal to sin y. This implies x is equal to n pi. So n pi plus minus 1 raised to n, and y, sorry, I am writing semicolon here, y is 4 pi by 3. So 4 pi by 3, n belongs to z. So this is a general solution of your answer, that is n pi plus minus 1 raised to n into 4 pi by 3, where n belongs to z. I want this first, right, because the condition is more important in these trigonometric equations, and very easy questions. Now cos x is half. Now cos is plus in first quadrant, all is for plus, and fourth quadrant, right, and half is the value for cos 60, that is cos pi by 3, cos 60, that is cos pi by 3. So cos is positive in first and fourth quadrant. First quadrant as it is, that is pi by 3, so we have to take only pi by 3. Never think for this another value. right? So cos is positive in first quadrant, so pi by 3. So cos x is equal to, it is given cos x is equal to cos pi by 3. That is cos x is equal to cos y. Then x is equal to, so this double implies x is equal to twice n pi plus or minus y. What is y? Pi by 3 and n belongs to z. So this is your solution set, right? So solution set of this is x is equal to twice n pi plus or minus pi by 3, n belongs to z, right? So you have to remember you require both same, but here it is given tan in cot, right? So what to do in this type of question? You have to change this into tan. Now you know tan pi by 2 minus theta. Tan pi by 2 minus theta is cot theta. Tan pi by 2 minus theta is cot theta. But this is given minus. So you have to take plus, means second quadrant it is minus cot theta. So this is due to given minus sign. I am writing pi by 2 plus theta, that is now in second quadrant, right? So pi by 2 plus, this is pi by 2, then this is pi by 2 plus theta. In second quadrant tan is negative and change, therefore it is cot, right? So tan twice x is equal to, I am writing now this as tan pi by 2 plus theta. Theta is this theta, so plus x plus pi by 3. So this is tan twice x is equal to 10. Now LCM of this 3 pi plus 2 pi, that is 5 pi by 2 into 3 6. So this is 5 pi by 6 plus x. 5 pi by 6 plus x, that you know, right? Now tan twice x, that is tan x is equal to tan y. And if tan x is equal to tan y, then answer is n pi plus y. So answer n pi, x is equal to, but instead of x it is given twice x. So therefore twice x is equal to n pi plus y, that is x plus 5 pi by 6. X plus 5 pi by 6 and n belongs to z. We have to find out the value of x. X is here also, so taking x to left hand side, this become x is equal to n pi plus 5 pi by 6, n belongs to z. So this is your general solution of given equation, that is n pi plus 5 pi by 6. So got it? Easy है ना? हाँ? कर सकेंगे ना? Okay. So for more example we have to clean this. So wait. So example number 23, page 77, solve sin twice x minus sin 4x plus sin 6x is equal to 0. As we discussed, when it is given more than two terms, then you have to take a proper terms. So if we add or subtract, then we get another third term. So if we take 6 and 2, then 6 plus 2 is 8 and divide by 2 we will get 4. So I am rearranging the term in this order. So here sin 6x plus sin twice x minus sin 4x is equal to 0. So rearranging the term. Now sin c plus sin d, formula for sin c plus sin d is 2 sin c plus d by 2 into cos c minus d by 2. This is your formula. So applying this formula, right, solving trigonometric equation means you have to factorize the given equations. That means from addition you have to make it into change into a multiplication form. So you can take common anything, right? Solution means you have to find out the factor of these equations in trigonometric function form, sine cos form. Okay, so applying this formula here we get 2 sine c plus d, 8 divided by 2, that is 4x, into cos c minus d, 6 minus 2 is 4 divided by 2 is twice x, minus sine 4x is equal to 0. minus sin 4x is equal to 0. So now see here, sin 4x is common. So taking sin 4x common, so sin 4x is common, what we get? 2 cos twice x minus 1 is equal to 0. So either a into b is equal to 0 means either a 0, either b equal to 0. So we can write sin 4x is equal to 0 or 2 cos 2x minus 1 is equal to 0. Now sin 4x is 0, that is set of zeros of sin x. So this double implies what we get? 4x is equal to n pi, n belongs to z, that is set of zeros for sine, you know very well, right? So we have to find out the value of x. So x is equal to divide by 4, this is n pi by 4, n belongs to z, this is one of the solutions. Now or this 2 cos x is equal to 1. So 2 cos x, cos twice x is equal to 1. So what we get here? Or cos twice x is equal to 1 upon 2. Now cos is half for cos 60, that is pi by 3. So answer of this is cos pi by 3. So cos x is equal to cos y. You know formula, cos x is equal to cos y. Then what you get? Solution. So if it is given cos x is equal to cos y, this double implies x is equal to twice n pi plus or minus y and n belongs to z. So this is your solution for cos x is equal to cos y. So here cos x is equal to cos y, but instead of x it is twice x. So I am writing this double implies twice x is equal to twice n pi, right? So twice n pi plus or minus y, y is pi by 3. So plus or minus pi by 3 and n belongs to z. We need x. So solving this, what we get? This double implies x is equal to divide by 2. This is n pi plus or minus pi by 6 and n belongs to z. This is your required general solution, right? So you have two general solutions. One is n pi by 4 and another is n pi plus pi by 6. So solution set, if you want to write solution set is equal to, in set bracket, this is n pi by 4. So n pi by 4, n belongs to z, union, or means union, you learn in set theory. So this or this, that is this. So n pi plus or minus pi by 6, n belongs to z. So for more than one answer you can write like this also. For single answer you can write this also, n pi by 4, n belongs to z. That is your solution set, right? Got it? So example number 24, solve the equation that is given 2 cos square x plus 3 sin x is equal to 0. We have to solve this equation, means all quantities must be in 1, either in sin, either in cos. If you want to change this into sin, you can easily change this. Applying formula cos square x is equal to 1 minus sin square x. You can change these all terms in sin. But if you want to change in cos, then for this sign it is not possible. So that's why I am changing this cos square into sin square to get all terms in sin. So if we multiply, if we write 1 minus sin square instead of x, then this is 1 minus sin square x plus 3 sin x is equal to 0. Now multiplying this, what we get? 2 minus 2 sin square x, right, plus 3 sin x is equal to 0. Taking minus common from this, because a perfect square term will be always positive, but here is negative. So taking minus common, I am writing this minus become plus. So 2 sin square x plus become minus 3 sin x, and this plus become minus 2 is equal to 0. Got it? Taking minus common and rewriting the term, I am writing this term first, plus becomes minus as we take minus common, and this plus become minus, right? So this is 2 into 2, that is 2 into 2 is 4. Now splitting out 4 and getting 3 is 4 1 ja 4, right? Last term is minus, so we have to subtract, and we need minus 3 after subtracting. So this is minus and this is plus. So 1 minus 4 is minus 3. So we get the middle term. So factor of this are, so you have to split out this is 2 sin square x minus 4 sin x. So minus 4 sin x plus sin x minus 2 equal to 0. Now 2 sin x is common. So taking 2 sin x common, so this is 2 sin x. Answer will be sin x minus 2, and taking plus 1 common, this is sin x minus 2 is equal to 0. Now again sin x minus 2 is common, so taking out sin x minus 2 common, this is 2 sin x plus 1 into sin x minus 2 is equal to 0. So this is a into b equal to 0. So either a equal to 0, either b equal to 0. So therefore what we get here, 2 sin x plus 1. So 2 sin x plus 1 is equal to 0, or sin x minus 2 is equal to 0. So from here what we get? We get sin x is equal to, that is 2 sin x is equal to minus 1. So we get sin x is equal to minus half. Now sin is negative. Sin is negative in third quadrant, and this is the standard value of 1 upon 2, that is sin 30, that is pi by 6. So sin is negative here, right, in third quadrant. And third quadrant, this is the standard value of 30. 30 is pi by 6 standard value. So in third quadrant, this is pi plus, that is 1 more than the denominator, is 7 pi by 6. Either you can write pi plus theta. So pi plus pi by 6, this is pi plus pi by 6, you will get 7 pi by 6, but directly it is 1 more than the denominator is 7 pi by 6. So this is 7 pi by 6. So what we get? Sin x is equal to sin 7 pi by 6. Now we have formula, theorem number 1, sin x is equal to sin y. So double implies x is equal to n pi plus minus 1 raised to n, right, into y. N belongs to z. This is the formula that we have to apply. So sin x is equal to sin y. So this is your y. So what is your answer? X is x only here. So therefore x is equal to n pi plus minus 1 raised to n into y is 7 pi by 6. N belongs to z. So this is your solution set. Now for this, right, or sin x is equal to 2, which is not belongs to the range of minus 1 to 1, that is sine range. Range of sine is minus 1 to 1, that is minimum value of sine is minus 1 and maximum value is 1, but this is 2. So this does not belongs to this interval, so which is not possible. Which is not possible. So you may get the only one solution, that is x is equal to n pi plus minus 1 raised to n into 7 pi by 6. That is your solution. If you want your solution set, then solution set is n pi plus minus 1 raised to n into 7 pi by 6. N belongs to z. This is your solution set. Got it? So question number 5, page 78. Solve the equation cos 4x is equal to cos twice x. It is given in standard form also, right? That is cos x is equal to cos y, but these both are in x. So you have to apply formula, means you have to make this a equation. So this equation should be cos 4x minus, taking this to left hand side, this is cos twice x is equal to 0. Now this is cos c minus cos d formula. So cos c minus cos d is minus 2 sine c plus d by 2 into sine c minus d by 2 formula. You have to apply this formula. right? So apply this formula, cos C minus cos D is equal to 0. C is 4x and D is 2x. So what is your answer? Minus 2 times sine C plus D by 2. 4 plus 2 is 6. Divided by 2 is 3x into sine C minus D. 4 minus 2 is 2. Divided by 2 is x is equal to 0. So A into B is equal to 0. That is either A equal to 0, either B equal to 0, because 2 is never equal to 0. That is minus 2 because constant. So what we get here? Sine 3x is equal to 0 or sine x is equal to 0. Now this sine x equal to 0 means set of zeros of sine, and set of zeros for sine is n pi, n belongs to z. So solution of this is, this double implies either, therefore x is equal to n pi, n belongs to z, or, and here again sine 3x equal to 0. So instead of x it is 3x. So set of zeros of sine, right? So set of zeros of sine, that is in x. This is 3x. So here you have to write 3x is equal to n pi, n belongs to z. So what do we get? X is equal to n pi by 3, n belongs to z. So solution set, if you want to write solution set, then solution set is equal to 1 is n pi by 3, n belongs to z, and another means you have to write union. So union n pi, n belongs to z is your another answer. Got it? Any problem? Okay. Now same question is question number 6. It's given 3 terms, and you know why more than 2 terms are given, then you have to rearrange the term so that if we add, you will get third term. So if we take 3 and 1, cos 3x and cos x, then 3 plus 1 is 4. Divide by 2 is 2. Here is 2. So it's okay. Is given already in form. So cos C plus cos D. We apply here cos C minus cos D formula. So now we have to apply cos C plus cos D formula. So cos C plus cos D is equal to 2 cos. This is C plus D by 2 into cos C minus D by 2. This is the formula that we have to apply, cos C plus cos D. So applying this formula, what we get? Cos C plus cos D, that is 2 cos C plus D by 2, 3 plus 1, 4, divided by 2 is twice x, into cos C minus D, 3 minus 1, 2 divided by 2 is x, minus cos twice x is equal to 0. Now to find out the solution of a trigonometric equations, that means you have to factorize the equations, right? So taking cos 2x is common from here, we have to factorize this. So if you can get any common thing, then you can take. So cos twice x is common, so cos twice x. So remaining will be 2 cos x minus 1 is equal to 0. So again a into b is equal to 0 means either a equal to 0 or b equal to 0. So this is cos twice x is equal to 0 or 2 cos x minus 1 equal to 0. First we solve this. So this is cos twice x equal to 0 means set of zeros of cos, and set of zeros of cos is twice n plus 1 into pi by 2, n belongs to z. So writing twice x is equal to twice n plus 1 pi by 2. This is pi by 2, n belongs to z. But we want solution of x. This is twice x, so divide by 2, 2 comes here, becomes 4. So what we get? X is equal to twice n plus 1 pi by 4, n belongs to z. This is one solution. Now another. Here, or. This is taking 1 to right hand side, this becomes 2 cos x is equal to 1. So therefore, what we get? Cos x is equal to half. Now cos is half for 60. That is pi by 3. So this is the value of cos pi by 3. This is cos pi by 3. And you have a solution set cos x is equal to cos y. Then this double implies x is equal to twice n pi plus or minus y. Right? And n belongs to z. This is the solution set of cos x is equal to cos y. That is your theorem number 2. So applying this formula, x is x and y is pi by 3. So what is your solution set? So x is equal to twice n pi plus or minus y. Y is pi by 3. So this is pi by 3, n belongs to z. So these two are your solutions, and if you want to write solution set, then solution set is equal to, this is twice n plus 1 pi by 4, n belongs to z, and union, this is twice n pi plus or minus pi by 3, n belongs to z. This is your answer. Got it? Okay, so only now I think how many questions are remaining? 3 questions are remaining that we will be seeing next lecture. Okay.